Sonic, the heart of your system.
What is up, guys? This is Luke Hill for Kicker, and this is the ASUS ROG Strix X570-E gaming motherboard. So this is ASUS's £300 X570 offering with a pretty beefy power delivery solution and some really cool features. Let's take a deeper look, shall we? So if we first start with a look at how the motherboard overall looks physically, of course this is an ROG Strix product, so we've got a typically dark grey and dark black styling. I personally think this is a very good looking motherboard. And then obviously you've got the plastic rear I/O cover with the Strix branding and the ROG branding on there. As far as RGB goes, we've got specific zones, and this Strix badge does actually light up, and it looks pretty good to say the least. We've also got some zones in different areas of the board. I'd say MSI's Mystic lighting approach is slightly better for the infinity display that we see with the Meg X570 Ace. However, this is a good board, it's an attractive board, and there's just enough RGB lighting to make that subtle difference. So looking first at the memory area, of course we've got 4 single latch DIMM slots, and these of course take DDR4 memory up to 128 gigabytes. You can support high-speed memory, but make sure you check the QVL for which memory modules you plan on using with this motherboard, and as is our typical advice for AM4 and X570 and Ryzen 3000 currently, I'd recommend using 3600 MHz DDR4 modules with nice timings, so you don't have to mess around with the Infinity Fabric and the memory clock divider. But if you're willing to do that, then yeah, go nuts, buy some high-speed memory kits by all means. So close to the DIMM slots, we've got this single outwards facing internal USB 3.2 Gen 2 header, so that's for 10 gigabit per second Type-C support on the front panel. And we also get a few other good to see items, so a bundle of fan headers that are well within reach of the CPU socket, and we've got 2 RGB headers in what I would call ideal location for top mounted or even front mounted RGB strips. Now in this top right corner, I really do like the inclusion of 4 post LEDs. So these are specific LEDs allocated to the CPU or the VGA, for example, and they'll tell you if there are any problems or any issues when you're posting. I think these are really good in addition to the debug display. However, it's slightly disappointing to see that we have no onboard power or reset or clear CMOS buttons to sit alongside these, and there's also no onboard physical voltage monitoring points to sit alongside these LEDs. So good to see the LEDs, slightly disappointing that we don't have any onboard buttons or voltage points. So storage nuts will be happy to see that we get 8 SATA 6 gigabits per second ports, which is ideal for use with older legacy hard drives, optical media, if you still use optical drives, larger, slower SSDs over the SATA interface. This is good to see, especially given that none of these ports share bandwidth with any other connectors, so you can use all of these at any one time, which is absolutely ideal. Moving along to the bottom edge, we have a pair of internal USB 2.0 headers, so ideal for use with all-in-one liquid coolers and RGB controllers, etc. Good to see a pair of those. We have the one internal USB 3.0 5 gigabits per second header, and it's slightly disappointing to see only one of these, especially because it's in such an awkward location. So if you've got a long front panel cable for your case, then this bottom edge location is completely fine. Some motherboards have it in this region near the 24-pin connector, which is also good and perhaps easier for some cases. But given that ASUS's own case actually supports 4 front USB 3 ports, it's slightly disappointing to see only one header included here rather than 2 that we typically see for boards of this price point. Additionally, on the bottom edge, we have another 3 4-pin fan connectors, so ASUS really does have you covered when it comes to fan headers. You've got another 2 RGB headers, one of which is the better addressable format. And then we've got this ideal 2-digit debug LED, so Q code LED, which can actually be adjusted in the UEFI to show you post information during post, and then also CPU temperature during system operation. And that's a really cool feature, but ASUS doesn't deploy this by default. So why this is not set by default, I do not know, but you can go inside the UEFI and change this. Cool feature, nice one ASUS, I like that. So when it comes to M.2 connectors, ASUS provides you with a pair, and both of these actually support PCIe, obviously Gen 4x4 SSDs, as well as SATA SSDs if you prefer, and they support drives up to 110 millimeters in length, so really good support there. So importantly, both of these connectors can be used at any one time. They don't share bandwidth with anything else, which is absolutely ideal. Disappointingly, ASUS provides only 2 when competitors at this price point are typically providing 3 M.2 connectors, and I actually think 3 is probably justifiable at this price point, because if you've got a fast drive for your OS, if you've got maybe a SATA M.2 SSD for your game storage, and then if you've got a fast drive for your Adobe Premiere or video editing exports, then that's 3 right there. 2 is not giving you a lot of flexibility, so that's quite disappointing, especially when ASUS ROG and MSI, for example, are offering 3 at this price point. So I criticised ASUS ROG for making the M.2 SSD installation procedure needlessly difficult, and ASUS gets the same criticism here. So this plastic shroud needs to be removed by 2 standard screws, and then you can remove the 2 heat sinks for the M.2 connectors. This is just kind of pointless, really, because the shroud is effectively dissimilar. It's not necessarily intertwined with the M.2 heatsink, so it doesn't need to be connected or in the way. If you've got a graphics card installed, that 2-minute procedure for installing an M.2 SSD is now a significantly longer procedure, especially if you've got an AIO graphics card cooler or, heaven forbid, a full custom liquid loop in there. If you find a new M.2 SSD that you want to install and you've got a full custom liquid build, that is going to be a really, really painful procedure for something that is fundamentally so simple. Now, it would be easy to look at these M.2 heat sinks and think, well, okay, never mind, the shroud can still actually be fit without the M.2 heat sinks there. So if you have an SSD like Gigabyte's Aorus PCIe Gen 4 SSD with a thick copper heatsink, or the Corsair MP600, you can just get rid of these M.2 heat sinks and use the heatsink specific to the M.2 SSD. However, that's not really the case, because there's no mounting location underneath which fastens down the M.2 SSD. So these heatsinks actually are used to leverage the M.2 SSD into place and stop it from deflecting upwards. So realistically, you're going to want to equip these heatsinks and ditch any heatsink that comes with your specific SSD, which is quite disappointing, to be fair. So we get the usual set of PCIe expansion slots. So of course you got X16 up top and X8 for the primary 2 if you use an SLI or Crossfire, both of which are supported. The 2 primary slots are steel reinforced and gives them an extra bit of stiffness, which is quite good if you're using a heavy graphics card and you really want to eliminate GPU sag. Good to see. Spacing is ideal between these 2, because you can use a 2.5 or a 3 slot card and still fit the second card in there, or you can have a cooling gap between a pair of 2 slot cards. Rounding out the expansion slots, you have 1 full-length PCIe slot, but this is wired as PCIe 4.0 by 4 directly to the X570 chipset. So this is good for high bandwidth devices, but not really a graphics card. SLI wouldn't be supported, and Crossfire would just be somewhat handicapped, to say the least. Worth noting is that this bottom connector does actually share bandwidth with one of the PCIe by 1 slots, so if you want to use both at the same time, the bottom slot will actually drop to by 2 bandwidth, and that can be controlled within the UEFI. So when it comes to audio, that's one of the areas where ASUS always puts particular focus with the ROG Strix products, and this Supreme FX system is built around the Supreme FX S1220A audio codec. So alongside the S1220A audio codec, you have a bunch of Nichicon capacitors for audio filtering, and you actually get 2 operational amplifiers. So as we've come to expect from motherboards at this price point, you get the plastic I/O cover and then the integrated rear I/O shield, and I just love this. I don't know why we didn't do it beforehand, but it's great. And Asus's one is actually very well built and installed really well, so credit to Asus there. Looking at the rear I/O, first of all we have HDMI 2.0B and also DisplayPort. So both of these will do 4K 60, and that's important for the HDMI because you can use an APU to output 4K 60 to a TV, for example, which doesn't have DisplayPort. Probably not relevant for this board right now, but if more powerful APUs come out in the future, that's really good to have. Moving along, we get an absolute host of USB 3.2 Gen 2 10 gigabits per second ports. In fact, all of the rear USB ports, including the Type-C connector, are 10 gigabit per second speed, and Asus deserves a lot of credit for doing this. Typically, I'd be happy to see maybe a couple of USB 2 ports just for keyboard and mouse, but the fact that every one of these ports is full 10 gigabit per second speed, that's ideal, because you don't have to worry about which port is correct. Am I installing my SSD or my thumb drive in the higher speed port? You just plug it in and it's as simple as that. You can't make the mistake. So credit to Asus there. So alongside the standard Intel 211AT gigabit Ethernet connection, one of the key points for this motherboard is the 2.5 gigabit Ethernet, and that's delivered by a Realtek controller. So I like to see this on a premium motherboard like this because it helps users who are really genuinely considering that switch to higher than 1 gigabit networking over the next few, perhaps months or years, which is a reasonable lifespan for a high-end motherboard like this. Good to see. Credits for ASUS there. Of course, when it comes to Wi-Fi, you get Intel Wi-Fi 6 capability, so that's up to about 2.4 gigabits per second in theoretical throughput. And then when it comes to audio connections, we've got our usual fare of jacks and obviously the optical audio output connector. So while ASUS includes the really useful BIOS flashback feature, which has worked very well in my own personal testing, and is very useful, especially if you're going to be buying this motherboard in the future and using a future CPU that perhaps isn't supported out of the box. Really good feature to see there. It can also help for resilience. So if your BIOS does crash or you're having any problems with display output, you just flash the BIOS and do some troubleshooting that way. Disappointingly, however, there's no rear clear CMOS button, and I would have liked to see that, especially on a motherboard of this caliber, which is going to be used by overclockers and tinkerers. So if we focus on the power delivery to the AM4 CPU, this is a really well-built, good power delivery solution. So primarily, we'll look at the heatsink, which is, okay, it's not bad as far as heatsinks go. You know, there's no fins, but ASUS has made a solid effort to try and increase the surface area by taking some slots and some cuts out here. It's got a tiered approach, and it's also got a flattened heat pipe between the two specific fin arrays. So yeah, I'd give ASUS some credit for this heatsink, and I like that ASUS connects the heatsink via thermal pad to the inductors as well as the MOSFETs, because that can just help a little bit. It's not necessary, but it helps a bit. So focusing specifically on the power delivery solution, you get a total of 16 power delivery phases, and this is split as 12 to the CPU and 4 to the SoC. So the controller behind this system is a DigiPlus ASP1405 PWM chip, and that is widely believed to be a rebadged International Rectifiers IR35201, and some of the behavior of the motherboard does suggest that. So a really high-end PWM controller, not a true higher than 8-phase controller like we see from Gigabyte with the Aorus Master and the Aorus Extreme, but still an absolutely superb PWM controller there. This is an 8-phase capable controller, and here we've got clearly more than 8 phases, so ASUS must be using doublers. Nope, ASUS doesn't use doublers, as we've seen for the recent motherboards from ASUS, and instead you get 2 sets of electrical components operated in parallel per single phase. So it's effectively a fat 6-phase deployed to the CPU specifically by using 12 physical phases, but only 6 control phases without doubling. And then the similar approach is deployed for the SoC, so you get 4 physical phases, which are controlled by 2 control phases from the PWM controller. Looking specifically at the components used, ASUS is using the absolutely fantastic International Rectifiers IR355 power stages, or power IR stages, I should say, integrated MOSFET solutions. So these are one of the best solutions on the market. They go 60 amp capability, so you're absolutely dripping in power delivery capability, especially with this decent heatsink. No worries for a 16 core or even higher end chips that are going to come out in the future. And then the SoC is using, each phase is driven by a IR3553, so still really high power overkill power delivery solutions and integrated power stages for the SoC, but clearly ASUS has gone all out on the power delivery solution here. So beneath this plastic shroud is the X570 chipset and the accompanying heatsink and fan. ASUS uses an open rotor radial design for the blower, and this is different to the axial fans that you would typically see obviously inside your case on a cooler. And this has some benefits when you're talking about small size for a 40mm diameter unit. In testing, this was a very good fan, so it stayed below 3000 RPM in pretty much all of our testing. X570 temperatures were high as we expect, but not overly high. And it was really unintrusive, to be honest. The noise was never a concern over the AAO pump that we were using. So credit to ASUS there. It's got a small fin array on the metal heatsink, and perhaps that does help to remove some of the heat from the X570 chipset. So even though fan is, not an ideal approach, as we've all come to agree with on X570, the fact that this is a pretty good fan with pretty good speed control and low noise operation, got to credit ASUS for that. One area with regards to the chipset fan, however, where ASUS does not deserve credit is the positioning. Now clearly, if you install a 2 or 2.5 or 3 slot graphics card in the primary slot with a specific vented cooler that vents inside your chassis, so basically all reference coolers for NVIDIA cards these days, or aftermarket cards on the AMD side and the NVIDIA side, that's just going to dump heat straight into the chipset fan. You're going to be using higher temperature air trying to remove heat from the chipset heatsink, and it's just not going to be a great solution. So the positioning is not as smart as it should be, but in our testing, which granted didn't really use heavy GPU loads because this is a motherboard review, we didn't see major concerns, but it's something that's worth keeping an eye on. So that's our closer look and overview of the ASUS ROG Strix X570-E gaming motherboard. Make sure you do go and check out the full written review on the Kikaroo website for more information regarding the software and the BIOS and the UEFI with a bunch of screenshots and more information regarding the motherboard. There's more detail over there, so check it out if you are interested. So our test system consists of the AMD Ryzen 9 3900X 12-core CPU cooled by a Corsair H100X 240mm AIO at full 1700 RPM fan speed. Memory comes in the form of a 2x8GB 3200MHz C14 G-Skill kit, which uses Samsung BDI ICs. Pixel pushing duties are handled by the beastly Gigabyte Aorus RTX 2080 Ti Gaming OC with a custom fan speed curve to minimize GPU boost clock reductions. For the SSD, we use a WD Black NVMe drive for the OS, Gigabyte's Phison-powered PCIe Gen 4 SSD for speed testing, and a Crucial MX300 for game storage. Power is handled by the absolutely overkill and highly efficient Seasonic Prime Titanium 1000 watt power supply, and we're using Windows 10 1903 with the latest updates and AMD power profiles. So to test this motherboard, we're using the latest BIOS revision, and that includes the AMD AGESA ABA microcode. So it's got the potential boost clock fixes that AMD suggested from the ABBA revision. Cinebench R20 shows strong performance from ASUS ROG Strix X570-E gaming using the latest AGESA ABBA BIOS. ASRock is still in the lead thanks to more aggressive default voltages and therefore clock speed boost. According to our logs, the Ryzen 9 3900X sat at an average of 40-17 MHz throughout this all-core load, with 1.235 to 1.25 volts being fed as the core voltage. Single-threaded performance from ASUS is okay, though we expect it higher given the use of the latest ABBA AGESA version with supposed boost clock fixes versus ABB on the competing motherboards. Our logs showed a maximum clock speed of 46-41 MHz, which translates into a 46.5x multiplier. That was for a single data point from our readings taken every 2000 milliseconds. The more reasonable single-core boost clock was 4.6 GHz, and the board allowed the preferred CPU core to spend a very healthy amount of time operating at more than 4.5 GHz. ASUS looks to have done a good job at deploying the AGESA ABBA BIOS update. Blender performance from ASUS is on par with that of Gigabyte's X570 Aorus Master. There is very little between the boards in this test, though ASRock is slightly quicker thanks to far more aggressive default voltage settings and poorer power efficiency. Memory bandwidth is where we'd expect for 3200MHz CL14 DDR4 in dual channel mode. ASUS's latency performance is slightly improved versus the competitors in our chart. ASUS's X570-E gaming memory bandwidth performance in Cysoft Sandra tops the chart alongside MSI's competitor at 36GB per second. The strong boost clocks help ASUS register chart topping score in 3D Mark Time Spy. 11,919 points puts the X570-E gaming 3% ahead of ASRock's competing X570 Taichi. Real-world gaming performance in Deus Ex Mankind Divided is solid enough. ASRock and MSI are marginally faster while Gigabyte is fractionally slower. The differences are minor and therefore ASUS does well enough in this game. The performance hierarchy for Shadow of the Tomb Raider is identical to that of Deus Ex. ASUS sits a frame or two behind ASRock and MSI, while the X570-E gaming's average performance is fractionally ahead of Gigabyte's X570 Aorus Master. Stepping back from the minor differences, there is no bad gaming solution out of these four motherboards. M.2 performance is right where we'd expect it, with our blazing fast Aorus PCIe Gen 4 SSD hitting almost 5 GB per second on sequential reads. Cooling performance from ASUS's metal heatsink is good enough, with our logs showing a peak drive temperature of 60 degrees Celsius for our relatively light speed tests. Read and write speeds in the 900 megabytes per second range are exactly what we should be seeing from ASUS's USB 3.2 Gen 2 10 gigabits per second ports. The audio performance, according to Rightmark Audio Analyzer, is strong, as we would expect from the Supreme FX audio solution that we've come to trust from ASUS. Overclocking with the ROG Strix X570-E gaming was a little less straightforward than it should be due to the limited understandability of ASUS's load line calibration settings. We were able to hit a stable frequency of 4250 MHz using 1.35 volts as set in the UEFI. We backed down to level 4 load line calibration. The level 4 setting saw a load voltage of 1.328 to 1.336 volts in Cinebench, which represents a 14 to 22 millivolt offset. The CPU temperatures were controllable at this level and stability was not compromised, so we were happy to proceed. With ASUS's motherboard overclocking the Ryzen 9 3900X to 4.25 GHz, Cinebench R20 multi-threaded performance increased by 402 points. Pretty reasonable if your workloads are primarily multi-threaded. ASUS applies sensible voltage levels to our Ryzen 9 3900X under stock conditions, and therefore the power readings from the wall are reasonable. 216 to 218 watts under load is just a smidgen higher than the power draw from the MSI and Gigabyte competitors, and is significantly lower than ASRock's overvolted X570 Taichi. Bear in mind that ASUS had our Ryzen 9 3900X operating at an average frequency of 17 MHz on the all-core with the latest AGESA ABB-A BIOS revision. Overclock numbers are less favourable to ASUS, with our own adjustments to the awkward LLC settings also being partly to blame. CPU-Z registered a core voltage of 1.328 to 1.336 volts under Cinebench multi-core load, though the power draw reading from the wall would suggest that the actual number is higher. Interestingly, the ASP1405 PWM controller that is used by ASUS is widely believed to be a rebadged International Rectifier's IR35201. That's the same PWM chip that is used on the MSI MEG X570 Ace motherboard, another competitor which exhibited similar, uncharacteristically high power draw for the given software read voltage level. The Ryzen 9 3900X CPU temperatures held around 80 degrees Celsius under stock conditions, thanks in large to ASUS's sensible voltage levels. Overclocked CPU temperature is more concerning at well above 90 degrees Celsius. The higher than usual power consumption observed in the previous chart translates directly into increased thermal output for the struggling AIO cooler to contend with. A steady state load temperature of 95 degrees Celsius with short duration spikes a few degrees higher would be enough for me to turn down the voltage and or frequency of this overclock if I wanted daily usage. VRM temperatures are excellent even with the system overclocked heavily. Less than 60 degrees Celsius under stock conditions and staying well below 70 degrees Celsius when overclocked highlight the efficiency of ASUS's power delivery components. These readings were recorded using our test equipment. ASUS does not provide sensor read temperature data in OS-based software such as HWinfo, which is disappointing as the vendor clearly has nothing to hide. Chipset temperatures were fine, showing the typical mid-60s reading for the X570 motherboards. ASUS's chipset cooling solution seemed perfectly adequate at managing the heat output without requiring excessive fan speeds. The small 40mm blower stayed below 3000 RPM for the vast majority of our testing. So overall, the ASUS ROG Strix X570-E gaming is certainly a premium motherboard from ASUS that sticks to its overall ROG branding by offering a particularly premium power delivery solution and a good set of overall features that quite impressed us throughout our testing. Now, stock performance was excellent, and that is thanks in large to ASUS's proficient inclusion of the AGESA ABB-A microcode revision, which had our boost frequencies as high as 4.65 GHz using a Ryzen 9 3900X. Overclocking was perfectly fine. We managed to take our chip to its 4.25 GHz all-core frequency. It was a bit awkward using the load line calibration settings because ASUS doesn't particularly make these clear, or they don't include any explanation as to what each setting does via graphical form like we see with competing vendors, and the voltage accuracy wasn't very good, or certainly the power consumption and temperatures of the motherboard and the CPU didn't tie up with the expected voltages. With that said, the board did run stably at 4.25 GHz all-core, even if it did demand a bit more power with our configuration. A bit more tweaking would be fine. So RGB lighting is good, perhaps not quite as good as MSI's X570 Ace, which has the Mystic Light Infinity, but obviously that's a slightly more expensive motherboard. Overall, I like ASUS RGB lighting. You get plenty of headers, you get good control, and you get some degree of control through the UEFI specifically, which is good to see. One of the slightly disappointing features is only 2 M.2 connectors are included, whereas most competitors at this price point offer you 3. Having 3 connectors gives you extra flexibility. It's not an absolute necessity, but it is giving you extra flexibility, which you should expect on a £300 motherboard. So it's a bit disappointing to see ASUS drop to only 2. With that said, the inclusion of a solid set of 8 SATA ports could have you happy in lieu of that third M.2 connector missing. One of the key features that I'm particularly impressed by is the inclusion of 2.5 gigabit Ethernet from the Realtek chipset. This is good to see at this price point, and if you are generally considering upgrading past your 1 gigabit Ethernet connection in the near future, this is a really good motherboard, and that does swing it heavily in favour of the ASUS board at this price point versus some of the competitors. The chipset and board cooling overall is good. Obviously you get this shroud on the bottom edge covering the chipset heatsink and the chipset fan, but also the M.2 connectors. Now this does make it needlessly awkward to install M.2 devices like we saw with the ASUS ROG X570-E, and that's especially important if you have a full custom liquid loop or an AIO cooler on your graphics card, at which point your 2-minute SSD installation is going to take you significantly longer. With that said, the heatsink's held up fairly well, so we don't really have any complaints there. And if we focus specifically on the 40mm fan on the chipset heatsink, that performed particularly well, staying below 3000 RPM throughout our testing. It was inaudible. The positioning is not ideal because it will be sucking in hot air from a graphics card, but in our CPU and motherboard focus testing, we didn't see this as a major issue. Overall, with the ASUS X570-E gaming, you get almost certainly the strongest power delivery solution at this price point. So if you want all-out power delivery for future-proofing this, or if you are going to push it with liquid cooling or some more exotic cooling, this is an excellent choice because you've got that 16-phase solution with really high-end components, even though you're lacking doublers, which is not really an issue in certain scenarios. I'd say at the £300 asking price, this board is good value overall, and it's probably one of the best options at £300, provided you're happy to deal with the slight shortcomings such as the lack of a third M.2 connector. And if you really are into your power delivery solution, if you really are considering going 2.5 gigabit Ethernet in the near future, this is a particularly strong option at £300. So I've been Luke Hill for Kit Guru, and this has been our review of the ASUS ROG Strix X570-E gaming motherboard. Thanks for watching. If you liked this video, hit like and give us a subscribe too. If you want to see more Kit Guru videos, make sure you check back on the Kit Guru YouTube page and also on the Kit Guru main website, where you can see our written reviews and this review in written form. And if you want to support us, do check out our merch store and our Patreon page. See you next time.